Hello friends, my name is Sushil Pandey. Welcome to my networking video series. Today topic is Network Essential Book. In this part, we will talk about LAN switching technology and WAN switching technology. Let's start switching technology.
Work of an organization may be limited to one location or may span multiple geographies. However, to connect a network, there is a need for different mechanisms that help in setting up the network and spanning the network to different locations. An organization's network can be a LAN, a WAN, or a combination of both. Organizations implement a LAN setup by connecting devices at a single geographical location. Similarly, they implement a WAN by connecting multiple LANs that span different geographical locations. Identifying LAN switching technologies. The smallest network is comprised of two devices that are connected to each other to enable communication. Connecting devices directly to each other helps in setting up a small network spanning only few computers. However, if there is a need to connect more computers, a networking device, such as a network switch, is required. Switches are intelligent network devices that are used to extend a network by allowing multiple devices to communicate with each other. Understanding the working of a switch. A switch is called an intelligent networking device. To make communication possible, it maintains a table called a MAC address table, which stores MAC addresses of the devices connected to the switch. The MAC address table contains the port number of the switch, along with the MAC address of the device connected on that port number. Whenever a packet is transmitted from a source to a destination, it first reaches the switch. On receiving the packet, the switch examines the MAC address of the destination node. Then, the switch consults its MAC address table to find the MAC address of the destination node. Understanding a virtual LAN. Consider the scenario of A1B1 Technologies. The organization's network consists of 1,000 users connected on a single logical network. Lately, network users have been complaining about the slow speed of data access. The administrator diagnosed the problem and determined the size of the network as the cause. Switches are used to extend a network by allowing devices to be part of a single network. This single network defines one single broadcast domain. A broadcast domain is a logical division of a network where all the hosts on the network recognize each other as devices connected through the same wire. Therefore, in a broadcast domain, devices can communicate with each other simply by sending broadcasts at the data link layer. In a broadcast domain, communication happens when devices send a broadcast frame that is received by all the devices connected through a switch. Understanding trunking. After the VLANs on a switch are created, the devices connected to the switch communicate only on the basis of their VLAN membership. However, the devices connected in the same VLANs will only be able to communicate with each other. For example, a computer in VLAN 1 will be able to communicate with all the devices of VLAN 1. However, it will not be able to communicate with another computer that is a part of VLAN 2. Therefore, to enable the devices of different VLANs to communicate with each other, a router needs to be used. A router is connected to a switch, and all the communication between different VLANs is routed through the router. For this, all the packets are first forwarded to the router that is connected to the. Understanding port mirroring. Port mirroring is a means to monitor the network traffic passing through a switch. It is also called Switched Port Analyzer, SPAN. When a switch is configured with port mirroring, the switch gets involved in monitoring packets. The switch monitors packets by sending a copy of all data packets that are received on one port or a VLAN to another port of the same switch. The other port can be connected to an analyzer, which can just be another computer. The following figure displays port mirroring for ports. Understanding port authentication. Consider the scenario of A1B1 technologies. Lately, administrators are facing the problem of overutilization of internet bandwidth. As per the company's security plans, the download of large files is restricted. However, the administrators find that some of the users misuse the internet connection for downloading large files. On diagnosing the problem, the administrators determine that users are able to download large files on their personal devices, such as mobile phones, smartphones, and laptops. Understanding port speed. Port speed refers to the rate at which an interface can transmit data. On a network switch or router, the port speed of an interface also determines the amount of shared resources that are available to the ports. For example, if a port is configured to operate at a dedicated transmission rate, the port resources are reserved for the configured rate even though the bandwidth is not used. You should be cautious while configuring the port speed on an interface, as changing the port speed can disrupt traffic on the port. Preventing loops. Consider the scenario of A1B1 technologies. The administrator designed the organization's network by interconnecting several switches through their uplink ports. Uplink ports are special ports through which two switches are connected to each other. However, understanding circuit switching. In case of circuit switching, instead of a dedicated line setup, an ISP or a telephone company establishes the connection between multiple nodes. When a network is set up by using the circuit switching technique, temporary data connections, or circuits, are established at the time of communication between the source and destination nodes. While the connection is on, only two nodes can use the channel. This means that the circuit is not available for any other communication until the circuit is terminated. Once the communication is over, the circuit is terminated and made available for the other data communication channel. A telephone Understanding message switching. In message switching, there is no direct communication channel between the sender and the receiver. The message is stored temporarily at the switching element and forwarded later. The message is always stored and forwarded in its entirety. The message is forwarded from the switching element, one hop at a time. Typical examples of message switching are email and fax. Unix to Unix copy protocol, UUCP, is also an example of message switching. UUCP is used to allow remote execution of commands and transfer of files, email, and news among computers.